Good morning, ladies and gentlemen of Precalculus. We're going to be working on these exercises today, 1 through 6, which have to do with, this section is related to polynomial inequalities, and you'll see that more succinctly tomorrow. But in exercise 1 through 6, determine the x values that cause the polynomial to be 0, positive, and negative. Now this is assumed to be a non-calculator exercise. What would be your strategy on this exercise here? Riley's just kind of...
Can you ask the question again?
Yes, what would be your strategy on solving this problem?
Factor.
Okay, factor, he says, right? But this happens to be already factored form, right? So factored form here, this makes it easier for us, but when we go to, well, they're all in factored form, okay. That should make this not too hard. What's going to be a strategy on this? Find what? I'll start with the 0, 1 with answer A. Okay, let's do that. All right. That seems like a good suggestion to me. All right, Elizabeth, so we're going to do this like this. We're going to have 0 equals this right here. Okay.
I would put 0 for all the x's.
So you mean for all the factors you're saying?
Yeah.
So x plus 2 is equal to 0, like that.
Yeah.
X plus 1 is equal to 0, like that. And x minus 5 is equal to 0. Okay, good. What else? So x equals -2, Elizabeth says. X equals -1. X equal to 5. So is that going to be your answer to part A? Yes, A, right? Okay. So that's part A. What about parts B and C? Now there are two different ways of doing this, one of which we have done for a few weeks now. You want me to remind you of what that is?
Yes, please.
Okay, what you do is you say, okay, well, so you have x, y right here, and you mark your x-intercepts here. So -2, -1, and 5. Okay? And what do you know about this function right here? You know you're going to, when you multiply all the x's together, what do you get? What do we get when we multiply these x's together? X cubed, right? And then also, one thing that could help us out is multiplying all these numbers together. We multiply 2 times 1 times -5, we get what? -10. So now we have like the leading term, and we have like a y-intercept down here of -10, which could help us. Okay? So what do we know about x to the cube functions? Where do they start and where do they end? This right here. Odd positive, odd negative, even positive, or even negative. Which is it? Even positive? You mean like this?
Yes.
What is even about 3? I don't understand.
Yeah, I thought it was odd positive.
You said odd positive? You meant odd positive, said.
I knew it was odd positive.
So she knew what she was doing, she just said the wrong word. Okay, yeah, that's right. Anyway, it's gonna be like this, right? So starts where, ends where?
Starts low inside.
Right, and then, what do we need to know about the multiplicity of, so we're gonna start down here, and you're gonna end over here, right? What do you need to know about the multiplicity of these zeros? Multiplicity is what? Equals 1. Multiplicity equals 1. Multiplicity equals 1. And all these 3 added together are 3. So we know we start low, end high. So we're going to start low. Multiplicity of 1 crosses the x-axis. Comes down here, multiplicity of 1 at negative 1 cross the x-axis. We know we come down here and we pick up negative 10, right? And multiplicity of 1 crosses or just touches the x-axis, crosses. Okay, that's what it's going to look like. You graph that in the calculator, that's what you're going to see. Okay, so now we're going to answer these questions. B positive, and I'm going to use this thing. So what happens is positive is above the x-axis, right? So all of this right here, what's above the x-axis is an answer for B. So B, positive where? Between negative 2 to negative 1 and union 5 infinity, right? And C, negative, where's the thing negative? Negative infinity to negative 2, and also
negative 1 to 5.
negative 1 to 5. So that's another way of doing it, and according to what we've done so far, you should have, because we've done problems similar to this, haven't we? Maybe not asking the same question, but doing the same thing, right? Here's what I want you to also consider doing, and this sort of gets us into where many of you are going to be headed in calculus next year, is you can make a number line analysis that you can say, you can put the critical numbers here, which are negative 2, negative 1, and 5. And we know these are critical numbers because these are the zeros, right? And so what you can do is you can take this equation right here and you can substitute in numbers. You want a number left of negative 2, you pick like, I don't know, negative 3, negative 4. What that would do is that would make this negative, and this negative. What's a negative times a negative times a negative? Negative. Okay, that's a sign chart. So that means we're below the x-axis. Okay, then between negative 2 and negative 1. Okay, if we take, what happens is this would be negative, this would be negative, but this would be positive. So what is that going to be? Positive. And then between negative 1 and 5, you can pick 0. What you'd have is you'd have positive times a negative, or negative. And finally, greater than 5, you'd have positive times positive times positive. So that's what's called using a sign chart. And you can use a sign chart without actually having to graph the function and still figure out what's going on. Does that make sense to you? Okay. Okay, good. What I want to do is have you work on number 2, I'll call somebody in a minute. I'll go take care of some paperwork in the meantime, all right? But you see how all these stuff we've talked about, like multiplicity, sort of ties together with this? Yeah, that's right. I didn't have some of your papers from last time. We didn't exactly 100%.
You do
Yeah.
or the last one, whatever it was.
Yeah, the last one, if you have this.
And I don't understand how to do that one.
Yeah, the last one. Don't worry about it. I'm not too worried about
I
it.
tried to do it.
Yeah. That's fine.
Is there one?
Yeah, quick review. Yeah, quick review. 2.8 quick review, 1 through 10.
2.8?
Yes, 2.8. I know we finally only got till 9, up to 9, so this is fine. Okay. Turn in some more work you've done too. Right, great. Thanks. Okay, I'll call somebody here. All right. Yes, yes. Call somebody. Okay, here we go. Number 2. Here we go, let's see what we got.
What was that?
It was Robert.
What was that? Nobody saw that.
I saw it. Yeah, it's kind of glitched out on us, but Robert's still on you. What's up, Robert?
Well, I made the x's into zeros. X minus 7 equals 0. 3x plus 1 equals 0. X plus 4 equals 0.
Okay.
And then starting from it's x equals positive 7. x equals 1/3. And x equals -4.
You told me -1/3, right?
No, I said 1/3, but I meant -1.
Okay, all right. I was just checking. All right. What next?
Then I did the symbol graph or the symbol number chart, like
The sign chart?
yeah, the sign chart.
Okay.
I was getting to. Okay, so I put -1/3 on the chart. And then 4.
How about -4 over here?
And 7 on the right.
Okay.
-5 would put it to the left.
So -5, plug in -5. We get a negative times a negative times a negative. So what's that going to be?
Positive.
3 negatives times each other. A negative times a negative times a negative is what?
Positive, negative.
Negative. Okay, between -4 and -1/3, what is that going to be?
-2. It's not negative.
-2, right?
Yeah.
So that'll be negative.
Negative. Right.
Yeah, that'd be negative. And then if you put -2, that's going to be negative also, right? And this one's going to be positive. So negative times the negative times the positive is
Positive.
positive. Okay, between -1/3 and 7,
3.
we'll have
Negative.
negative, positive, positive, which is
Negative.
negative, and then positive, positive, positive. Okay, so you ready to answer the questions A, B, and C now?
No. Oh. That's as far as it got.
As far as you got? Okay. I'm going to show you a little shortcut on these two in a second. It can help you figure this thing out. Okay,
A is x equals 7.
so
That top part.
So A is x equals 7, x equals
-1/3.
-1/3, and x equals
Negative.
-4. Okay, so that's part A. Okay, part B is
From -4 to -1/3. Union from 7 to 5.
Okay,
C is from negative infinity to negative 4. Union from negative 1/3 to 7.
okay. I want to show you something you can do with these things. What is the multiplicity of each of these zeros?
1.
1. So multiplicity equals 1 for each. Well, what that means, if multiplicity is 1, it means sign is going to change every time. So it means if we find this sign to be negative here, and the multiplicity of this 0, negative 4 is 1, we know that it'll change signs. So you say, okay, multiplicity 1, change signs, multiplicity 1, change signs, multiplicity 1, change signs. You see how that could be helpful to you?
Yeah.
And you didn't really have to graph it or anything like that, so you just found out what it was, okay? Good. I want you to look at number 3, and I think number 3 is also in factored form, so it shouldn't be too bad to do, and I'll choose someone else for that here within another couple minutes. Okay, here we go. Let's see who's going to help us with this one. It's going to be Karina. All right, Karina. All right, Karina. What do you have here?
A is x equals number 7, negative 4, 6, and 6.
Like that? Okay. What next?
And then b is negative infinity, negative 7, parentheses. And then the u thing, the negative 1, other infinity.
Okay.
And then z is negative 7, and negative 1.
Like that?
Yeah.
Okay. how come 6 is not here? I don't see 6 anywhere here.
Or, yeah, it's
Yeah. Okay. This is one that's a little, let's work it, is that when you put these right here like this, right? You you have -7, -4, and you have 6, right? Well, here, to the left of -7, you got a negative times a negative times a positive, right? This is always going to be positive here, isn't it? Right? That's where you have that. Except where it's 0, right? Won't be positive at x equals 6, but everywhere else positive. So in this interval, you have a negative times a negative. So that'd be positive there. And you go here, between -7 and -4, you're switching over this multiplicity of 1. So that means you're going to change signs to be negative, like you have here. And then at -4, you change signs again to be positive. And so you're positive, because that's positive times positive, positive, and positive, positive, positive here. But what's happened is that the thing is exactly 0 here. So what that is that makes that kind of, that means you have to split this part up a little too, right? Because because 6 is included in here, it's not 0, it's 0 is not positive. So what you have to do is you have to split that up like this. Okay, positive here, and also positive for greater than 16. You see why you have to do that? Okay. All right, good job. Any questions on that? Everybody see why you had to make that? We had to make that little split here. Okay, good. All right, I will have you on 4 and have you pick somebody on 4 in just a couple of minutes. I just want to say one more thing. As you go left to right, this is a multiplicity of 2, so you don't change signs on a multiplicity of 2. There we go. All right, number 4. Let's see who's going to help us with this here. We got Elizabeth. All right, Elizabeth, what do you think for number 4?
First sentence was the A. It's going to be X equals A factorials.
This is what I get for this. Is that right? I mean, it's, her answer was close enough to right. I know she just kind of,
Both ways, because when you divide by 3, you get 6 or 1/3. So repeat 0.
so you subtract here, right?
Then you just,
Divide by 5x equals negative 3/5. Okay? So that's one of them. Then what else?
And then out of the square root of 6,
square root of 6.
square root of -6,
You didn't get anything here? Okay. Then what else? Are those the only ones we have? Yeah, that's A right there. That's all we have for A. Okay?
No, you don't have one for the x squared plus 6?
Let's check that out.
Because I know you have to square root, take the square root of 6.
So subtract 6, we get x squared equals negative 6. We take the square root of both sides. X is equal to square root of negative 6. What's the square root of negative 6?
2.44. 2.44, I'm not sure.
I,
Square, I'm not sure what I have my calculator set at. Do I put a square root of negative 6? Non-real answer. That's what I was looking for. Non-real answer. So what that's telling us is there's no real number that works for this, that'll make this negative, or 0, okay? Can't be 0, no solution. So now, what is part B here? Where's the thing positive? Okay, we got negative 3/5 and 1. So this is always here going to be positive, right? Where it's not, it's always going to be positive. This one right here, to the left, we're going to have negative times a negative, right? And this would be negative here. So we got
Negative.
positive times negative. So we're negative here. What about between negative 3/5 and 1? Multiplicity of 1, right? Change of signs, positive. And at greater than 1, change of signs yet another time. Something is wrong here. Positive, positive. To the left here, it's going to be positive. That'll be negative, negative, negative. Okay, so this has to be positive here, right? Then you change signs here. So this will still be negative, but this would be positive here. And then over here you'd have positive, positive, positive. So you'd have
Negative 2, negative 3/5.
right? And then your negative is only going to be in here.
Negative 3, okay, 2, 1.
Did you graph it? Anybody graph it and see the same thing there? Riley graphed it. That makes sense. Yeah, this thing here is kind of a curveball to the whole thing.
I kind of like doing this symbol chart or
This-
sign chart.
You like the sign chart?
Yeah.
Yeah, it is. And really, I want to make sure we got to it this year because we didn't do this last year in pre-calculus. And I can see that students can get to it. Okay, let's get to number 5. So do number 5, I'll call on somebody. We're sort of running a little bit low on class time, but let's go ahead. Go ahead and get somebody else here. We got, I'll call somebody in just half a minute here. Get Elizabeth some credit. She worked on it. Yeah. Elizabeth got a curveball thrown at her. Didn't you? You didn't like that one? You got a sneak attack. So that's part of it. That's how we can learn sneak attacks. All right, number 5. Let's see who we got for number 5. Looks like we'll have Becky for number 5. Becky, all right. What'd you get for 5, Becky?
So at first this one was confusing to me,
Okay.
and I figured out with the first one, x equals, and we have to be square roots, because negative 5 over 2.
No, this one here is just like, it's just like this thing right here. Never negative, okay? So you're not going to have anything,
No, it's just gonna be 5
any
over 2.
zero at all related to this. So you'll have x equals
8.
8, and x equals
Negative 1.
negative 1. And what are your multiplicities here? Multiplicity
Of 2 and multiplicity.
equals 2. Multiplicity is equal to 3. Okay, what next?
I did the,
Did a sign chart? So you have negative 1 and 8, is that right?
Yeah. So,
And to the left side of negative 1,
0. Oh, wait.
it's gonna be,
one thing you could do is because of multiplicity, you could start at 0. So let's just start at 0. If we plug in 0, well, this is always going to be positive here, right? But if we plug in 0, that's going to be positive also, right?
Yeah.
So we have a positive times positive, that's always positive. So this is positive here. And then we can look at multiplicity of 3. Is that going to change signs?
Yeah.
Yeah, so this is going to be negative here. And we go to 8,
it's gonna be positive.
it's going to be positive also, right? Because we don't change signs.
All I did was, for B was negative to infinity.
So
Negative
positive,
1
yeah, we have
to
negative,
infinity.
well, actually, it's not to because we have that 8,
Yeah,
with
yeah,
0 at
put
8.
the 8, and then-
So we got to break it up here at 8, and then 8 is infinity.
Infinity.
And then
It's
C,
negative infinity.
negative infinity to negative 1. Okay, so that's going to be that one. And we are really, we've really run out of class time on this. I don't know if we're going to be, how much time we'll have tomorrow, but we've got to really wrap up for that. So I might have you turn it in tomorrow, but that'll be it for class today, okay? Let's go get disinfected here. Thank you.